Welcome to the free Jamb Mark series for Jamb UTME 2026. Do not forget to obey the lecture protocols by making your notes as you are taking this lecture. Momentarily, in between the lecture, pause the video and take notes. Anything you understand, take it down because you are going to need it after this lecture. Do not also forget to enable full screen view in your device by tapping on the icon located at this place that I'm hovering my mouse. Without wasting much of our time, let's look at the Jamb repeated question 1. Jamb repeated question 1. Question says, in a Daniell cell, which of the following correctly identifies the anode and the cathode? In a Daniell cell, which of the following correctly identifies the anode and the cathodes? A. Anode is copper, cathode is zinc. B. Anode is zinc, cathode is copper. C. Anode is zinc, cathode is zinc. D. Anode is copper, cathode is copper. What's the answer? Let's find out. Remember, cells are also known as batteries. Okay, so let's find out the answer. I can give you 99% assurance that this question is going to be repeated in your Jamb UTME 2026. You are going to see this question in your Jamb UTME 2026. That is for sure. So that's why you have to make notes, take this lecture seriously, and lend me your ears. Let's go. Primary cells. First of all, we have to understand what primary cells are, or what cells are. Like I told you before, cells are batteries. That's what cells are. They are batteries. They are known as batteries. Okay. So there are two types of cells, or there are two types of batteries. The first type of battery is the primary cells. And what are primary cells? Batteries that are neither rechargeable nor reusable. You can't recharge them, you can't reuse them. It's single-use battery. Once you use it once, it's gone. It's damaged forever. For life, it's bad for life. You can't use it again. Once used battery, not rechargeable and not reusable. The next fact about primary cells is having irreversible internal chemical reaction. And this is the reason why it's not rechargeable and reusable. It does not have a reversible internal chemical reaction. Okay? So for batteries that are rechargeable, when you plug them, the current applied to the cell induces a chemical reaction. Okay, it starts reversing the chemical reaction. All the ions that has been discharged from the positively charged electrode are transferred to the negatively charged electrode. So the positively charged electrode becomes charged once more. So that's what happens when you charge the battery. But in these primary cells or primary batteries, you can't recharge them because there is no irreversible chemical reaction. That chemical reaction in it, as you are using the battery up, is discharging the ions. The ions are discharging. So when it discharges its ion completely, the reaction cannot be reversible. So that's why it cannot be charged. So another fact about the primary cells and battery is stores energy for a long period of time when not in use. So a primary cell or a primary battery, you can use it to store energy for a long period of time when not in use. That's why you can purchase Tiger battery, for example, and keep it for years. And immediately you bring that remote battery, all those batteries using remote, immediately you bring that remote battery and insert it in a remote, it works. But for rechargeable batteries, when you charge them and you don't use them for 1 week, fortnight, 10 days, 14 days, and so on and so forth, they run down, okay? So they run down, they easily discharge, okay? They discharge on their own without usage. That chemical reaction just occurs spontaneously in the cell. So let's look at examples of primary cells. The first example we have here is Daniell cell. And Daniell cell is also known as the zinc-copper cell. The zinc-copper cell. Why is it called the zinc-copper cell? It's called the zinc-copper cell because one of the electrode is zinc and the other is copper. So what cell type is the Daniell cell? It's known as the primary cell, also called the voltaic cell. So it is the Daniell cell that is referred to as the voltaic cell. And the electrode used in the Daniell cell in the anode, which is the negatively charged electrode, okay? In the anode is negatively charged electrode. The cathode is the positively charged electrode. In electrochemical series, that's when anode is the negatively charged electrode and the cathode is the positively charged electrode. In electrochemical series. But in electrolysis is the direct opposite, is vice versa. In electrolysis, the anode becomes the positively charged electrode, while the cathode becomes the negatively charged electrode. That's why I say you have to be taking notes. You have to be writing down. Write down anything you hear, anything you understand in this lecture. Pause the video momentarily and make your notes, okay? So it's vice versa in electrolysis, okay? So anode here is the negatively charged electrode and zinc is used as anode in the Daniell cell. While in the cathode, which is the positively charged electrode, copper is used as the positively charged electrode in the Daniell cell. And the electrolyte present in the Daniell cell is the zinc sulfate, which is the zinc tetraoxosulfate 6 in the anode. So in the anode, there is zinc tetraoxosulfate 6, but in the cathode, you have copper 2 tetraoxosulfate 6 actually. That's what you have in the cathode. So just have it in mind that you have the tetraoxosulfate 6 of zinc, okay? You have the tetraoxosulfate 6 of the electrode in the anode, and you have the tetraoxosulfate 6 of the cathode in the cathode too. So the anode is zinc, the cathode is copper. Let's look at the next primary cell. The next primary cell we have here is Leclanché cell. The Leclanché cell is also known as the zinc manganese dioxide or manganese oxide cell. You can call it the zinc manganese dioxide cell. Why is it called the zinc manganese dioxide cell? Because one of the electrode is zinc. The other electrode is manganese dioxide. The cell type is classified under the primary cell, and the electrodes used in this cell, on the anode, which is the negatively charged electrode, zinc is used. Then the cathode, which is the positively charged electrode, carbon rod surrounded by what? Manganese dioxide or manganese oxide is used. So carbon rod is coated with manganese oxide as the cathode, which is the positively charged electrode. So what is the electrolyte present in the Leclanche cell? The electrolyte present in the Leclanche cell is the what? The ammonium chloride paste. Okay, it's in a paste form, and this is the main electrolyte. Jamb can ask you, what is the main electrolyte of the Leclanche cell? The answer is ammonium chloride paste. Do not forget to put that paste. Okay, it's in a paste form, and sometimes you might have zinc chloride added. So Jamb can also ask you, what is the secondary electrolyte of the Leclanche cell? So the answer is zinc chloride. Or they can ask you, what is the second electrolyte in the Leclanche cell? You can say zinc chloride. Zinc chloride is the answer. The third primary cell we have here is the Zinc-air battery. Zinc-air battery. And it's classified as primary cell. It's a primary battery. And the electrode used on the anode, which is the negatively charged electrode, zinc is used. Zinc metal is used. While on the cathode, positively charged electrode, oxygen from air reduced on a catalyst is used. Usually a carbon-based electrode. So oxygen is bubbled into a carbon-based electrode and is used as the cathode. Okay, so that's it. Oxygen bubbled into a carbon-based electrode. A catalyst is used to initiate this reaction to form the cathode. So let's say it's a carbon-based electrode. So you can see the electrode, that's the cathode, which is the positively charged electrode. You can see the cathode among the options, you see it as carbon electrode. And the carbon electrode usually used here is graphite most of the time. Graphite is used most of the time. So let's look at the electrolyte. The electrolyte used in the Zinc-air battery or Zinc-air cell is the aqueous potassium hydroxide or sodium hydroxide. So aqueous potassium hydroxide or aqueous sodium hydroxide is used as the electrolyte in the Zinc-air battery. So let's move on to the secondary cells. What are secondary cells? Secondary cells have the following properties. What are the properties? The first one here is batteries that are rechargeable and reusable. They are rechargeable, unlike the primary cells. The secondary cells are rechargeable and reusable. You can recharge them when they have discharged all their ions, or when they have died, or when they have run down. You can recharge them and reuse them. They have reversible internal chemical reaction, which is usually activated by charging. So after all the ions have been discharged, you can reverse the internal chemical reaction and make the ion move to the place that is supposed to be by charging it. So this is activated. This ion movement or ionic exchange is activated by charging the battery or charging the cell. Another fact about the secondary cell is that it stores energy for a shorter period of time when not in use. So when you are not using a secondary cell, it stores energy for a shorter period of time. Okay, so it does not store energy for a longer. That's why when you charge your phone has a secondary cell in it. So when you recharge your phone and you put off your phone and you keep your phone for 1 week, when you come back and you on that phone might not charge. You are not going to get that same 100% you left the phone in. So you are going to get a battery, a drained battery. Okay, the battery the battery must have been drained after 1 week. So that is the property of secondary cell. Stores energy for a shorter period of time when not in use. So whether you use it or not, provided you store that battery, is going to keep discharging its ions. Okay, it's going to discharge ion and eventually run down and die. So you might need to recharge it in order for you to redirect the ions into the place that is supposed to be, and the battery becomes charged once again. Moving on. So examples of secondary cells include lead acid battery. So the lead acid battery, which is also known as the lead dioxide battery, is a secondary cell, and the electrodes used on the anode, which is negatively charged electrode, lead metal is used, while on the cathode, which is the positively charged electrode, lead dioxide is used. So the electrolyte used in this battery, which is the lead acid battery, also called the lead accumulator, the electrolyte used is dilute sulfuric acid, which is dilute tetrasulfate 6 acid. What kind of form is it in? Is in the dilute form? Okay, you have to take note of that, because you might find that in your Jamb UTME. They will ask you what kind of acid is found, what kind of electrolyte, or what is the electrolyte found in the lead acid battery or the lead accumulator. So what are you going to pick? You might see concentrated tetrasulfate 6 acid there, and you might also see dilute tetrasulfate 6 acid there among the options. What is the right option? The correct option is dilute tetrasulfate 6 acid. You have to be specific. So let's look at the next secondary battery or cell. The next here is the nickel-cadmium battery, which is also called the nickel-cadmium cell. What type of cell is it? It's a secondary cell, which is a rechargeable battery. That is the property of a secondary cell. And the electrolytes on the anode, which is negatively charged electrode, we have the cadmium there, while on the cathode we have the nickel-2 oxide hydroxide. Okay, on the cathode. So in the cathode we have the nickel-2 oxide hydroxide in the cathode, and the electrolyte in this battery is the potassium hydroxide solution. The potassium hydroxide solution. So have it in mind that in the Zinc-air battery and the nickel-cadmium battery, they both share electrolyte, which is the potassium hydroxide. But the little difference is that in the Zinc-air battery, The potassium hydroxide used there is in the aqueous form, okay? But this one is just an ordinary potassium hydroxide solution, okay? So take note of that. Moving on to the next secondary cell. The next secondary cell we have here is lithium-ion battery, which is the most advanced battery of today. Lithium-ion battery, the one currently in your device now, the device that you are using to hear this lecture, there is a high percent chances that you have a lithium-ion battery in that device that you are using to take this lecture. So lithium-ion battery is a great breakthrough technology in battery making. So the type, it belongs to the secondary cell, which deems it rechargeable, and the electrodes used is on the anode, which is negatively charged electrode, we have graphite, while on the cathode, which is the positively charged electrode, we have lithium metal oxide. Okay, this is the chemical formula, lithium metal oxide. Okay, that's the chemical formula of lithium metal oxide. While the electrolyte used in this lithium-ion battery is lithium salt in organic solvent. So you have an element and a chemical compound combined together, a lithium salt and a solvent combined together. So the solvent used here is fluorine. Okay, fluorine is the solvent used. So this is the compound in carbonate solvent. In carbonate solvent, fluorocarbonates. Okay, so fluorocarbonates, the fluorocarbons. So lithium salt is mixed with the fluorocarbon, okay, to form the electrolyte used. So lithium salt in organic solvent or fluorocarbon is used as electrolyte in a lithium battery. So let's go back to the Jamb repeated question 1. The question reads, in a Daniell cell, take note of the keyword Daniell cell, which of the following correctly identifies the anode and the cathode? A, anode is copper, cathode is zinc. B, anode is zinc, cathode is copper. C, anode is zinc, cathode is zinc. D, anode is copper, cathode is copper. Remember what anode is and what cathode is. What's the answer? D is not the correct option because the anode is not copper and the cathode is not copper. C is not the correct option because the anode is zinc but the cathode is not zinc. A is not the correct option because the anode is not copper. B is the correct option because the anode is zinc and the cathode is copper. Let's look at the answer. Correct. So option A, wrong. Option C, wrong. Option D, wrong. The correct option is option B, which is anode is zinc, cathode is copper. In a Daniell cell, the anode is zinc and the cathode is copper. Jamb can also set the question in another way by asking you what electrolyte is found in the Daniell cell. You know the electrolytes. In the anode, you have zinc tetraoxosulfate 6, while in the cathode, you have copper 2 tetraoxosulfate 6. Those are the electrolytes. So they can ask you from any of the cells. So that's why you have to take this seriously and earn this mark. Thank you so much for taking this lecture. Do not forget to subscribe and follow for more at Nkwado Augustine across all social media platforms. I know that this lecture was beneficial to you. You must have learned one or two things that will be beneficial to you in your Jamb UTM in 2026 and beyond. Hope you made notes. Hope you paused the video momentarily and made notes while taking the lecture. Do you have any questions on knowledge gap? Do you have any topic that you want us to treat or any question you want us to solve? Do well to drop them in the comment section and I will do justice to your questions and knowledge gap as soon as I come across them. Once again, congratulations on earning your free 1 mark in Jamb UTM in 2026. Congratulations. At this point, I'm out.